Alright, well, hello physical science students, and welcome to this video lecture on density. I hope you're all not missing me too much today. So let's just jump right in. This may be review for some of you. However, first things first, we need to know what density is before we can talk any more about it. And our basic definition for density is that it is the amount of mass per unit of volume. Okay, now that's our very formal definition. We can simplify that a little bit and put it in more of layman's terms, and we can just say how much stuff in a certain amount of space. Okay, so how much stuff do we have in a certain amount of space? That's our most basic definition of density. The more proper definition is the amount of mass we have per unit of volume. Now, with a lot of things in science, we not only have a verbal definition like I just gave you for density, but we oftentimes have a mathematical definition as well. And we have that for density. So there is a formula that we have for density. We say that density is equal to mass divided by volume. And this formula should make sense because in our definition we're saying density is the amount of mass per unit of volume. What this word per means is we have some sort of division going on there. Okay, so we have mass per unit of volume. Now, an easy way to remember this formula, I call it the pyramid method. So I just draw a pyramid, and in the bottom of my pyramid I have two spots, and this first spot is going to get filled with D for density. The other spot down here is going to get filled with the V, and then the top is going to be filled with M. Okay, now in problems that you might have to solve regarding density, okay, I can ask you straight up to solve for density, and you just have to use this equation. However, if I have you solve for mass, you're going to have to do some algebra to this equation. Now, this isn't a math class, so I'm not as concerned that you can rearrange this algebraically. So this pyramid is going to come in handy, okay? Let's say that I do ask you to solve for mass. Well, what you do there is you're going to cover up M, okay? You're going to cover M up, and what are you going to have? You're going to have density times volume, okay? So let me draw that in here. You would have density times volume. Now, let's say that I asked you to solve for V. We'll cover up your V in your pyramid, and you're going to see that you have mass divided by density, or you have mass over density, and that's going to tell us that we're dividing mass by density. So if you cover up the V, you're going to have division over here. And then finally, if you cover up the D, if we're looking for density, okay, you're going to have mass over volume. That's just our equation. So you're going to have division if we're looking for density as well, okay? So again, if we're looking for density, you can just use this equation right here. However, if I ask you to solve for mass or volume, we can use this pyramid as a quick tool to make sure that we know which math operation we need to use there. So next, moving on, what are the units for density? Well, if we take a look at our equation up here, we see that we have mass over volume. So mass units, typically, well, our base unit for mass is grams, okay? And now this is a little goofy, but the units that we typically use for volume when we're working with density, we typically use milliliters. Okay, so grams per milliliter are typically the units we're going to use for density. Now, we have a relation where we say 1 milliliter is equal to 1 centimeter cubed. So what that means is we can also have units of density of grams per centimeter cubed. Okay, so really milliliters here and centimeters cubed are interchangeable, all right, because we know that 1 milliliter is equal to 1 centimeter cubed. In some unique cases, we may see one more additional unit for density, and that would be kilograms per liter. Okay, now this would primarily be used if we were dealing with much larger objects than we're going to be dealing with. Okay, but typically what we're going to be using is grams per milliliter or grams per centimeter cubed. Now I have some other quick notes that I want us to go through here. The first is that the density of a substance is always the same. Okay, now why is that? Well, the key reason is that density is a physical property. Okay, now remember, physical properties describe matter. Okay, so whatever matter we're working with, it's going to have this physical property of density. So that particular matter is always going to have the same density value. It's never going to change for that type of matter. Okay, a really prime example of that is liquid water. Okay, liquid water always has a density of 1 gram per milliliter. It's always 1 gram per milliliter because that is a physical property of water. Next and final note is that density does not depend on the size or shape of a substance. Okay, now to make this a little clearer for you, I want you to think about an ice cube. Okay, it's ice. Now I want you to think of an iceberg. Which one is bigger? Well, obviously the ice cube is bigger, okay? And it has a funkier shape than an ice cube. However, think about an ice cube in a glass of water. And I want you to also think about an iceberg in the middle of the ocean. Both of those objects float because no matter the size, no matter the shape, they're both still made up of ice. So ice has a very specific density. And no matter the size or the shape, that density is always going to be the same because we can relate back then to this note. Okay, the substance is always going to be the same. And because of that, size or shape of a substance does not affect density. All right, so there is your introductory video lecture on density. We're going to be getting deeper into this in the coming days. You're going to be delving into it a little bit today with the online lab. So, hope this was helpful, and take care, physical science students.